Wow.
These are just MCIs.
Yeah, so these are we're using this
60.
facility right now as a storage facility due to COVID because we had no ridership and we lost a lot of where there's no steps, and the batteries are actually going this way from one edge of the bus to the other edge of the bus. So there's 4 there. They're literally about 2.5 feet wide, about 1.5 feet tall, and about 7 feet long. And we can see them better. There's 2 more underneath the bus. Right up in front, we have the charging rails that we can charge up to 450 kilowatt hours. So theoretically, in about 15-minute charge at 450, I can get about a 15 to 20% state of charge increase. Then we have battery pack, then the AC, then another 2 more battery packs, and the black box back there, that is the heating and the cooling of the batteries. The batteries have their own HVAC, so to speak. So we try to keep we keep the batteries between 75 and 85 degrees Fahrenheit at all times, regardless of the temperature outside.
You don't want the fluctuation that will ruin the batteries.
Exactly. And even before you charge, the buses are at the optimal temperature.
So the charger goes down, or does
the charger goes down. It's pantographed down. It's J3105-2, I believe.
So nobody has to plug it in like a car.
No, those will be installed at PNC, and the installation will start sometime in November.
November for January.
Supply chain. So we can function without the overhead charger initially, but after a while we will have to use it. So as the batteries start degrading, right now the batteries are 100%, right? So as the batteries start degrading, so instead of 200 miles, we'll start getting
something else.
That's the facility.
That's the chiller over there. The bus, it's all right now.
Running right
high
now.
frequency band.
Yeah, so that's the AC that you're heating and the coolant pumps. So that you have the battery HVAC that's running right now, plus the coolant that circulates for the passenger cabin, plus the AC might come on and off.
So have you taken a lid off of this thing,
yes.
or is it always open?
What do you mean?
Well, is it always open like that?
That's the way it is.
Okay.
That's the way it will run down the road.
What did you say about those 2 rails up front?
For charging?
Those are charging. They are overhead charging. There's a pantograph that comes down, and he charges the bus at 450 kilowatts.
Wow.
So if the state of charge, the batteries are between 40 and 60%, I can charge them at 450. Once they get to 80%, they cut them off because then you start overheating the batteries for no reason.
Will we see that?
Yes.
Okay.
Well, not now. You will see it sometime in January because that will get installed in November.
So I assume that is 3-phase, but I only see 2 bars there.
Actually, it's DC charging.
Oh.
So this bus is completely DC charging. The charger takes care of the conversion from AC to DC.
And so are you saying actually those bars are electrical conductors?
Yes.
Something.
Yeah. So if you see.
The white thing on top.
Yeah, so the one close to us
Yes.
and to the back, that would be your positive, that would be your negative. The one far away from us and towards the front, that would be your positive, right? So they are
A little bit of red in it.
yeah.
I don't see them offset.
So if you see the orange cable, right?
Yeah.
Right. You see the ones close to us on your black. That's your negative. And the ones
It's not the whole length.
No. So that way they don't short out. They're 4 pieces.
Okay, I see your other electric vehicle right over there, that white.
Just to charge 10 buses at one location, I need minimum 1.5 megawatts of power, which doesn't sound a lot, but doesn't sound like a lot. But if I do that at peak time, and the overhead charger takes 0.6 megawatts, and I had charged 2 buses with the overhead charger at the same time, that's 1.2, with all buses 1.5 megawatts. So now put that in perspective. If I start doing that all the way across town, there could be some points that if we have these overhead charges all over town, there could be a 10 megawatt demand all of the sudden, and can the grid absorb that 10 megawatts? Or that's where CenterPoint told us the more electric buses you get in, we will need to know how you charge, how much, when, so they can get backup generation ready to be able to absorb the impact to the grid.
Do you pay a demand charge also?
So the first year, no, they will leave us alone on purpose, right?
They're
So
learning.
the first year they leave us alone so they can see our charging profile, to see how we charge and what we do. And the next year, the second year, they will set our rates based on peak demand, on demand, and everything else. What they told us is, we will tell you when we're going to on-demand charges so you can limit your charge. Because at the same time, I can tell the charger do not charge more than 10 kilowatt per hour. Just keep it as low as possible so we don't hit those on-demand charges. But if I need, we're a transportation company, we transport people, right? But if I need to put the bus back in service, I will charge it at full 150 kilowatts because I need to get it back out there in 2 hours. So
you may see, instead of having a number of buses that all try to charge midday like in noon, even if some don't need it, you may get them to charge others in the afternoon at half amount versus the one charge in the middle if you can get under a pantograph.
Well, that's the problem with these park and ride buses, right? They run in the morning and they run in the afternoon. It would be perfect if I could charge them during the day and I had a bunch of solar panels somewhere and just charge them back up. But I mean, people don't realize the amount of power. I mean, this bus has 564 kilowatt hours of batteries. I mean, that's
5 Teslas. Yeah.
Almost 6, right? In some
almost
cases.
6. Yeah.
So, and when I tell people my regular charger for this bus is what Tesla calls a supercharger. That's my regular charger.
Right. Right.
So, and then my supercharger is 3 times what a Tesla supercharger is. So, it's just when you start telling people that the amount of power that is required, and CenterPoint actually came to us and they told us, for example, this location, we cannot get more than 450 kilowatts of power. That's it. There's no substation close enough that I can get more than that. Well, yeah. But again, now we're starting to talk into millions and millions. That's the AC that kicks on. We have other locations where I can get up to 5 megawatts. So that limits the amount of buses I can put at each location. So now we can go down to the buses.
Okay.
What about, is there any kind of requirement that it gets up to 10 green power?
Stop it now.
No, just let it run. It'll run forever.
We increase the electricity that we buy. Right now we have a requirement of 50% green. And every year we stop it. So by 2030 we want to be 100%. So next year will be 60. The year after that 70, and so on and so forth. So
The argument against EVs is that they don't have tail back there, but you have a long tail tied to the pole. But the grid's getting cleaner all the time.
but I mean, in Texas,
Charging cables down there.
There's also natural gas.
See the green curb and the wires?
Yeah.
You have one of your speakers.
Charge pillars that will be at the plug-in.
Did you look into natural gas and propane and
Yes, so
hydrogen and biodiesel?
So the whole biodiesel,
I can relate to both.
the Cummins doesn't really like biodiesel. The injectors that they use, they do not. They either atomize the biodiesel that they're too good at doing it, or they're not doing it enough, and it doesn't want to start. The diesel engine does not want to start. The Cummins diesel engine doesn't want to start with biodiesel. But we're running B5 right now in all of our buses, and we looked into renewable diesel. It just does not make financial sense whatsoever. I mean, we would bankrupt ourselves.
You gotta look at the economics. I mean, as much as something
Can't be socially responsible if you're not in business.
Yeah, I mean, we would have to charge everybody $10 a ride to be able to, and then everybody's gonna start driving their cars because it's too expensive. So it's a give and take, right?
Yeah, it's gonna hurt the cause, not help it.
Yeah.
So do the drivers of these electric buses receive special training? That's what you hadn't gotten there yet.
We did. We train right now because we're doing mostly show and tell, and we're doing testing. We only train 3 people, but then Seth drives the bus. I have another employee that drives the bus when we're doing secret testing, so to speak.
Secret?
Yeah.
It operates just like a
Yeah. So we'll take it around and you'll
I
see.
see the sign with the fire hat that says fire.
Yep.
Fighters don't cut this. So,
You can just cut this and it's done.
so are you talking with the fire department of how to put out a fire in one of these?
Yeah, so we haven't really done any huge training other than testing because I'm waiting. I will have 2 more buses by the end of this month that will show up. So then I will be able to take this bus and leave it with the fire department and be able to give 1 or 2 day presentations. Right now, everybody wants a piece of it. So it's really hard to just, I don't really want to take it apart because if you break one of the communication pins, the bus is down and out for an extended amount of time. So I don't want to take that chance yet.
So that's decals like
Is
that.
that a fan noise?
Nope, that is the coolant pump
Okay.
that for the passenger cabin.
Okay.
So I can keep on forgetting the acronyms a little bit, but I can tell you how it works and it's a little bit better. So all the orange cables, we know what they are, high voltage cables, right? So right here, these 6 cables are all the 6 battery packs. Like I said, there's 4 on the roof and there's 2 more down here. You will see a battery down here and there's another one right here, right? So the power comes in here. These 3 right here will be your charging ports. So left, right, left side, right side, overhead. And then we also have power. This goes in DC power in each one of these slices. This slice provides power to this alternator or accessory box. This gives power to the AC compressor. This one is for the battery HVAC. This cable right here is for the air compressor for brakes and suspension. And then these other slices right here are 12 volts. And each one of these slices is 200 amps. So combined, we can get up to 600 amps, not 12 volts, I'm sorry, 24 volts. Wow. We get 24 volts out of the 24 volts, 200 amps out of each slice. So if it goes over 150, it starts another slice and another slice and another slice. So and at the same time, so they don't overheat and they don't get overworked, only 2 slices work on one time and they swap in between them. And everything is modular. So let's say that one of the phases, this also what this does, it changes DC to AC 3-phase for the traction motor, which is buried under there somewhere. Yeah. So let's say one of the phases goes out in this cube. We take the cube out, we take the slice that is damaged, we put another slice in, we put it right back, and we're done.
Do that here without sending it to the factory?
Well, as of right now, no, because this is the latest generation of battery electric. This system is made by BAE. This system is actually used in the M1 Abrams tank. So, not yet, but we will be able to do it in the future. But so that is warranted, this piece, that piece, and the traction motor, they're warranted for 12 years. So, they're thinking that we will not have an issue for 12 years. So
they built it with
yes.
reliability. They didn't have
yeah, and this
warranty work.
Exactly. And this right down here, it's our heater, the electric heater.
Is this deployed worldwide and they have some experience with?
So this is only used in the NOVA bus in the US. And right now, there's only about 40 buses built with this. So like I said, it's the latest and greatest technology. But if it works for the Army, it will work for us, right? I mean...
Is it kind of like a train where the train is using DC motors but has a big generator?
Yes.
That's how M1s work. Okay.
Yeah. So this kind of does exactly the same thing, only that AC motors are much more efficient. The AC motor that I have in this bus, it's generation 2.5. They actually, so this is generation 3, but the motor is generation 2.5. They have generation 3, which uses permanent magnets, and it's much more efficient. It's more like a 9-phase motor instead of a 3-phase, so it's still the same 3 phases, but they just overlap. So that's coming up in the next 2-3 years. I think that's what's going to be on our fuel cell buses in 2025.
I don't think I ought to touch anything standing in water.
No, you're good. I promise
He's
you're
been
good.
doing it. He's been doing all this.
So I've already went. So there's no way for electricity to escape. So even if I disconnect one battery, it automatically, all I have to do is, I'm not going to demonstrate it, but even if I just pull the tab, it automatically disconnects the battery and shuts down the whole bus. So not only each battery has its own contactor inside, but there's no way for it to leak electricity, even if one contactor does not want to open completely. So there's safety everywhere. It just does not.
So if one battery goes bad, it's not going to cascade the whole system?
No, so if one battery goes out, that's the beauty of the system. It's smart. It automatically kicks that battery out. You can keep driving. It just tells you, hey, you have reduced range. And the state of charge, instead of showing, let's say you have 60%, right, 10% per battery. If one battery drops off, all of a sudden the bus will show you 50% state of charge. So this is how much you have left. So figure it out, go back.
Batteries are bad.
Yes, it will. You have to plug, I don't have the laptop with me, but you can plug out the laptop and it tells you, we cannot quite get down to the cell level because these batteries are still brand new and they don't want people to get in them and figure out all the secrets yet. But we can get down to the cell level, and I've seen the engineering computer, how they got in it. They get down to the cell level, they can see the temperature, they can see absolutely everything. So let's say one cell is bad. What the battery can do, not only it isolates itself from the rest, but it tries to isolate that one cell, it disconnects it, and it isolates it, and it overcools the battery to make sure there's no thermal runaway happening. So they can, the system is very smart, and on top of that, there's no fire suppression system that can put a lithium battery out. So
Where is engineering headquarters for these, and where they manufacture also?
So the buses are manufactured in Plattsburgh, New York. The engineering headquarters are in Montreal, Canada, but it's a Canadian company that they build them in the US for US content, right? Because we have Buy America. This bus is 70% Buy America compliant. That's where the bus is. For BAE, they are in Albany, New York. No, not Albany. Endicott.
What?
Yeah, it's in New York. No, it's not in Albany. It's in west of Albany, about 2.5 hours. I think it's Endicott or something like that.
And by the end of the year, you'll have how many?
I will have 20 of them.
20.
Yes.
And I assume the mechanics probably go for a month somewhere to learn.
Well, no, we actually do all of the training here.
They come here.
They come here.
The representatives
That's
come
good.
here. So since we already have hybrids, we are already trained on high voltage. Most of our mechanics are already trained on high voltage. They already know how to swap out batteries. We actually, currently, we build our own batteries down to the, not down to the cell, but to the
Module?
pack, to the module, right? So we already build our own batteries. We know how to discharge them. We know how to put them back up to a certain voltage to build our lithium packs back up. This is not really new to us.
Yeah.
Everybody, when we first brought the buses, like, oh my God, what are we going to do? They came in, they looked at it, like, well, it's exactly like our hybrid, but just there's no diesel engine and it doesn't make noise.
Yeah, you hear a lot about the anti-EV crowd talks about buses and Teslas catching fire, and that's so rare, though. It's like,
Well, and to be honest, most of that happens due to maintenance.
okay, human error.
Endicott.
So you say you actually assemble battery packs here, test them, load test them, charge them?
Yep.
Wow.
Not for this bus, but for our
The hybrid.
but for our hybrid buses, yes, we do.
What's the temperature range on this? The extremes of heat and cold? Because extreme weather is the enemy of EVs.
So this bus was tested down to -20 Fahrenheit, and it's gonna go in a thermal chamber in a couple, not this bus, its brother. It's gonna go in a thermal chamber all the way up to 115. So all Houston Metro buses, we test them in a thermal chamber. We do all of our AC testing. The bus has to be able to go from 110 to 72 degrees inside temperature in 30 minutes. Which in an electric bus does not really make sense because we lose a lot of power. So we made a compromise. We said, fine, we don't want to do it in 30 minutes. We'll let you do it in 45 minutes, but you have to let me preheat or pre-cool the bus while it's plugged in. So that way I still leave with the bus where it's 100% and the bus is full inside.
That's saying it's different than a liquid fuel bus.
Yes.
It doesn't make any sense to have a pipe.
Well, if it's a Canadian company, it's gonna deal with the cold and.
Right, but everyone who's driving electric knows that
Oh, yes.
before you leave home, you
And,
heat your vehicle.
and everybody says that the cold weather is what kills the batteries. In the case of this bus, the cold weather is not really going to kill our batteries because we maintain, right, we keep the batteries at a certain temperature. What kills the range is the electric heater, because it's a 30 kilowatt heater.
Is it resistant?
Yes,
Yeah, okay.
it's resistant. I mean, that's the only way you can get it, right?
Well, a heat exchanger,
Well,
but
yeah, but where am I going to get the heat from? So I got to create heat, to make heat, to put it in for the passenger compartment.
a heat exchanger are very popular in even in Canada, though, as far as I know.
So,
Yeah.
well, no, all electric buses are built this way.
Oh, really?
So what I'm working with HVAC bus companies right now to get a heat pump, where my
That's-
consumption will be the same in the winter and in the summer.
Okay.
So in the winter, we don't get below 20 degrees Fahrenheit really in Houston, and if you do, it's a day or two, and everybody stays home anyway.
Right.
So we'll run the CNG buses, then we'll keep
Right.
these other buses parked. But I'm having a little bit of pushback because it hasn't been tested yet. I've been working on that for about 5 years. For example, I've been working on I've been working on the electric bus project to bring electric buses into Houston since 2016. So we didn't just wake up one day and say, we're buying electric buses. It's been very methodical and
Sure.
calculated, but then the bug hit us and it put us back another year or two, and it just, supply chain and everything just, we were supposed to have all 20 by now, but
So how much, I'm talking about dollars and cents, how much does this cost over its regular diesel counterpart?
so this is $1 million. Diesel bus right now costs about 650.
Almost 400,000 more.
Yeah.
Wow. Yeah.
No,
But over the longer, with fuel and maintenance.
No, David, no.
They doesn't get there?
Because if one of these goes out, and they will go out,
It will.
all battery packs, for today's price, for me to replace all 6 batteries in this bus costs over $300,000.
Almost the premium charge.
Yeah, so whatever savings I had, or whatever I'm doing, they're completely gone the moment I have to replace one component. That's about 90,000. This is about 70,000. So, and then on top of that, you gotta remember, it's still a bus. I still have axles, I still have brakes, I still have suspension. So, and the bus is heavier, therefore I'm going to wear out the suspension much sooner.
Special tires too.
No, so there's no special tires for heavy duty electric vehicles because they are already rated to 80,000 pounds.
Okay.
And we cannot really put a hard compound on the buses because we'll start slipping, and we have to put a special air pressure in them to make sure we have the contact patch. But then you put more people in it, then I have to increase the air pressure or decrease the air pressure. So you can do that in your car because you always know the weight of your car. It's always going to be you and the passenger. Plus minus 100 pounds does not make a difference on a tire, right? But on a bus, 5,000 to 6,000 pounds, that makes a difference. And then we could overheat the tires, and we could be underinflated, overinflated. So that's why there's no really.
Do they adjust the air in the tires while they're running? No.
No, that's why we're not doing
yeah,
it.
yeah.
Night rider stuff.
Yeah.
I don't know if they do.
Can we do it?
You kneel, right?
Yeah, but the suspension, it still has airbags. Would we adjust the air pressure on the tire based on the pressure on the airbags? Yes, but that's another system that's going to break. That's another system somebody's not going to maintain, and we're back to just put the 110 psi in
Because
the
I know
tire and let it
our
go.
selling point for EVs is that in the long run, it'll save you money on maintenance, like one of these, save you on maintenance, on fuel and gas and diesel, but where's the dollar savings on this over its diesel?
We haven't done it yet,
Okay.
because to be honest, you're already paying a $400,000 premium. We haven't really figured out our electricity rates because
As far as
so I know there's some transit agencies where
here high voltage.
their per mile rate it's right in line. If they don't have something worked out with their co-op or their energy company, it's actually more expensive it's like $3 a mile compared to like $1.25 for diesel because of the electricity cost. So that's what needs to change. We have to have some sort of legislation where we say, okay, transit agencies pay one flat rate no matter what. Is that going to happen in Texas? I don't know.
Yeah.
But I can show you the charging port real quick.
Oh yeah.
So there's a charging port right here on this side. And this is where the batteries are. I can actually open this whole thing. Sorry, you're not scratching. Okay. So this is the part that frustrates me about electric vehicles. We are still dependent on a lead acid 12 volt battery.
Yes.
$300 worth of battery die, $1 million worth of bus, it's out.
Right. A lot of maintenance, a lot of testing, a lot of inspection.
So right now I'm actually looking into, you know how all the fishermen have trolling motors, right? And they have those lithium batteries on them. And the BMS cuts off the battery once it gets to like 50%. So I was thinking, and then you have a button that you push and it gives you a little bit of power just to wake up the bus so the electric alternator kicks over and whatever. So I'm gonna let the bus run like this for about a year, and in about a year I'm gonna put actually a lithium ion trolling motor 24 volt battery in there and just test it out and see one of those 200 amp hour 300 amp hour batteries just to see what happens.
So the newest Teslas, they've got.
Oh, that's regular J72 unless that comes
Except for
up.
those two, yeah.
Okay, so that makes it.
I think that's your DC there.
Oh yeah.
The other is AC.
Yeah, no,
So what
they
did
won't
you
do
say
it.
about this
So that's why you
method
want,
of charging
because I think
versus
what Tesla does,
with the
actually the
pantograph?
car is the BMS instead of the battery having
yeah.
its own BMS.
I think they
Which
do plan to use that
Yeah.
connection.
That's why
Yeah, I'm not
friend
sure what
always
the
looks for
difference is.
the second and third
Well, this
generation
clearly
anyway.
doesn't have the amps. that
Well,
the
so
other one
this
does.
is
Yeah, I would say
theoretically a
not.
third generation electric bus. It's not the first generation, it's not the second, it's close to the third generation electric bus. It's a complete package, like the whole drivetrain is from one company. If you look at the other bus manufacturers, the batteries are from one company. The traction motor, it's another company. The BMS, it's another company. It's a mush posh and it's just put together and you're hoping that everything will communicate and work. Whereas this, the batteries are Volvo, the bus is Volvo, but then everything that has to do with propulsion is BAE, so it's one system. And actually BAE is what controls the batteries. So then, in all reality, it's just a whole entire propulsion system, it's one. Instead of having the traction motor from Siemens, this from so on and so forth, it's just one.
I know there's some companies that convert ICE buses into electric buses, but you're dealing with something that was never intended to be an electric bus in the first place.
And this is where a lot of people are thinking, why don't you do it? Can we do it? Yes, but you got to remember this is a steel welded frame, and fatigue will get to it after a while. So all buses are tested for 500,000 miles or 12 years. We actually, on our buses, get close to 1 million miles in about 13 years. That's how long we keep them, 13 to 14 years. All of our diesel buses, these actually we keep them 15 to 16 years. And the 40-foot buses, I don't think we have any here. I think there's some on the other side. Those are 13 to 14 years. So by that time they have 1 million miles, stress cracks starting to appear. And then all of the sudden, yeah, okay, fine, I'll take everything out, but then I'm gonna put about 5,000 pounds worth of batteries up top.
Yeah, and you got those stress cracks
Yeah,
already.
that frame might not have been built to take that much weight up top. So then I have to reinforce the frame, I have to do everything. I have to get an engineer to do an engineering study on it, can he take it, can he not take it? And then I put it in and the bus breaks 2 months later because the
Big
bus
pothole.
cracking happens, right? So that's why we don't, usually we try not to retrofit the Houston Metro buses unless there is a safety issue. If there is a safety issue, we will retrofit. If it's not a safety issue, we will introduce new technologies into the fleet every year because we buy 100 buses per year, every year minimum. Because the buses have a 12-year range, so to speak, plus minus. And we have about 1,200 buses. That's why we replace 100 buses per year, and slowly but surely, we are a technology of choice property. So we're not gonna say, we're only gonna do electric. No, we're gonna have electric, we're gonna have hydrogen, and then whatever else happens after that, we keep introducing it. So it also helps us with breakdowns, right? Because if you have all of the buses are exactly the same, and something catastrophic happens in one, I guarantee you will start happening in all of them. So we try to minimize the impact to our fleet at the same time. So we still can provide the service to our customers no matter what.
So you are going to get hydrogen.
So I'm working on that right now. The problem is the
You hold
fueling
us.
station.
Just keep it close to him.
There are no standards for hydrogen like there are for CNG. Everybody says there are, but then when you go and you read it, and I go to the fire marshal and I tell him, hey, I'm about to bring hydrogen buses in, he will give me a blank stare the same way he did when we brought CNG in 2014. He says, what do you mean you're bringing hydrogen? You're bringing CNG in Houston in 2014. Hindenburg. Yeah, and everybody, and the same thing with hydrogen. And what people tend to forget that the Hindenburg, what you see that's burning, is not hydrogen. That was the tar and everything else, the wood and the tar, the tar that everything was developed in. So we already have most of our facilities ready for CNG. All we have to add are optical sensors for hydrogen. But again, my problem is the actual infrastructure. They have some in California, and I did the whole tour of California, and I learned a lot from them. As you know, hydrogen gets hot when you go from liquid, you go to gas, and then it gets compressed again, and you try to put it in the tanks, it heats up.
Energy loss.
Yes, exactly. So what I'm working with actually the petroleum guys, because they know what they're doing. They're the best at it. We're never going to get rid of oil no matter what anybody says, because I mean, we're wearing it.
Lubricants, petrochemicals, plastics.
Yeah, so you're not going to get away from it. So I'm talking with them, and we're looking at a system where we use, instead of compressing the gas, we compress the liquid. 3 liquid pumps, we compress it to over 10,000 psi in liquid form, then we'll let it vaporize, and as right before it gets into the bus nozzle, we also inject some more liquid hydrogen to bring it down to -40. So we actually inject really -20 to -40 gas hydrogen into the tanks, so then I can actually fill the tanks to their full capacity, 95, 97% capacity, instead of trying to increase the PSI to 7,000, 8,000 PSI to get the same capacity. So that's what we're working right now, and that is coming.
Okay, you mentioned that this really doesn't have, right as of now, a cost savings. What's your selling point to the public, to the politicians?
Cleaner air. So I don't see that's what everybody goes after. So the way I look at it, what we're doing is we are cleaning up the air in Houston.
Yeah.
Right? That's all it is. If we try to if we keep talking about money, we're not going to do anything ever. So it's much better to just say, hey, let's clean up the air.
Yeah.
Let's make sure there's no noise, less noise pollution, less emissions. That's what we should be talking about. Now, will we get some cost savings from them? I'm pretty sure they're there. We just haven't gone through the whole testing phase to know what those are yet.
You're waiting for real world
Yes.
results.
Yes.
Now.
And you say that 50% of your electricity is green.
Yes, I mean
gonna
the
go up.
50% of the electricity in Texas is green, right?
Yeah.
We get it solar, we get it from wind, And then we have 10% that I know is nuclear, which you cannot get any greener than that, so to be honest. And the rest is natural gas and coal, right? So I think we're green. Texas is the greenest state in the United States, to be honest.
Yeah, red
Compared-
state goes green.
Yeah, so it's, and that's where we're going. And a lot of people are asking, are you going to do your hydrogen on site? No, because it does not make sense. First, I have to have electricity. That electricity is going to come from somewhere. You have an electrolyte. Then you have to store the hydrogen. Then you have to compress it. And then you have to cool it before you compress it. And after you compress it. So it doesn't make sense. When I have all these petrochemicals companies, and I can just go get liquid hydrogen from them, store it just like I would do propane, literally, and then just take 10 to 12 minutes, charge the bus, and go out there for another 350 miles.
Yeah, there's no free lunch anywhere. There's less
No.
expensive lunches,
Yes.
and I always say that the most natural form of transportation, the horse, has its own form of pollution. Horse urine, horse defecation, dead horses. So
Well, and like I said, we have to do something, right? If we want to clean up everything, we have to do something. And the other reason, we have to think in terms of jobs also, right? So why not keep the jobs here? Why not use the hydrogen from these guys that are literally keeping us, they're keeping society going, right?
it is literally.
So why not keep the jobs here? Houston is the transformation energy capital of the world, right? So why not just go ahead and do that? So that's why we're going more towards, let's keep the jobs here. And they're very high-skilled jobs. Somebody's going to have to maintain that hydrogen facility. The same thing with the chargers. We need more electricians. We need. Sorry, I'm really passionate about this.
Yeah,
I've been
so
working on it a lot, so. So what percentage? So right now we're buying 20 electrics now. We're gonna buy about 10 to 15 hydrogen. Then we're gonna turn around buy another 10 electric just to start seeing what we need. So pretty much what we're doing, we're not really putting the hydrogen and the electrics head to head because it's not a fair comparison. I know the hydrogen bus can go 350 miles. But it's also, when I take a diesel bus out of service, I cannot replace a diesel bus with just one electric bus. It's usually 2 to 1 or 1.5 to 1. I don't have the space to add another 200 buses per facility to be able to do the same routes that I'm doing with diesel. So what we're doing, we're looking at having electric buses on routes that are less than 180 miles, and we're looking for longer range buses that do 350 miles will go to hydrogen, and then if we're allowed, we'd like to do the longer range buses in some sort of natural gas or whatever else is coming out, right? These buses, for example, the park and rides, they're 55,000 pounds.
When I left here,
And they're heavy, and they need to go at 70 miles per hour.
I was at the same thing.
Because if you go on the HRB lane or on the highway at 60 miles per hour, nobody's gonna like you and everybody's gonna call on you. Plus the passengers, they're used to a certain type of service, right? They're used to that 70 mile per hour run. So right now there is no bus, that electric bus or zero emissions bus that can replace the park and ride. So we're working towards that. We're working towards fuel cell, 250 kilowatt fuel cell with a 300 kilowatt motor, so we can get to that 70 mile per hour and maintain that 70 mile per hour for at least 50 to 60 miles. Because then the battery starts depleting, you're gonna pull over a little bit, let the battery charge back up, and then keep going. But yeah, and it's kind of interesting because all of the new generation of hydrogen buses, they have a fuel cell, but they have lithium titanium oxide battery, the same as the Prius, how everybody was laughing at Toyota. Well, it's kind of funny, we're all going back to that because those actually work.
Yeah, because the buffer is
Yeah,
not your main
that's all it is. Yeah,
source of-
you have, I think, 33 kilowatts of battery power just because the fuel cell is not continuous. It's not going to give you 120 kilowatts continuous. turns on, turns off, turns on, turns off.
The
So
bus accelerates,
Yes.
decelerates, stops.
well, no, even the fuel cell itself is not continuous. It literally you just
So
yeah.
both, that's what I'm saying.
Yeah.
Both the fuel
Yeah,
cell,
so-
which goes into the buffer
Yeah.
battery, and how you pull it out of the buffer
Exactly.
battery. You don't want to abuse the things
Exactly.
upstream because
Yeah.
you're going to drive the bus as a bus
Yeah,
is
and
driven.
that's
Right.
that's the
That's
problem.
why I say it's in between. You need
Yep.
that buffer, but it's interesting they use the same battery chemistry.
Yep.
That
Well, so like I said, I've been working on it for a while, and actually it was very interesting. And Toyota gave a presentation at Bus World in 2019, and it was the chief something operation officer for Toyota, and he said, all of you laughed at us in 2000 when we came out with the Prius, when we came out with the hybrid. What's the #1 hybrid in the world? The Prius. Said, all of you are laughing at us right now because we're not going electric. And he said, wait and see.
Okay, all right. I like that.
So what Toyota is actually planning on doing is plug-in hybrids. They will have a very small selection of electric cars. They will be literally sold as city cars. So there will be that short range of 150 miles where you just come home, plug it in, just the grocery getter, soccer mom, go drop off kids, come back. And I think that's where everybody will be going to shortly but surely.
so which variety of lithium is this?
This one has lithium iron phosphate batteries.
It is iron phosphate.
By the way, Cyfair Independent School District is going electrical school buses. Yeah, and we're trying to get them to talk to one of our events, but it's school's out, so they're not going to be
So
communicating.
actually a school bus makes sense, right? Because what does a school bus do? Go in the morning, drive for 30 miles, come back, park,
Perfect.
plug it back in, go back in the afternoon, 30 miles, come back.
Perfect.
It's done.
Most if the football team has to go out of town for a football
Oh,
game.
I guarantee you they'll have propane
They'll
or
keep-
CNG
yeah,
buses
keep
for that.
A couple of those, yeah.
No, we're never gonna, I don't want to say we're not going to go away from fossil fuels, but they will still play a role in everything we do.
Nothing else, petrochemicals.
Yeah.
Yes,
Yeah.
there'll be something there. I mean, you cannot make energy out of nothing. I mean, even algae takes energy from the sun, transforms it into something else, then you have to
Come in a tank and
Yeah.
da-da-da-da-da.
there's more to it. You cannot just get nothing out of nothing. It's just not gonna happen. Something out of nothing. It's just not going to happen. I'm sorry.
And economics rule the day.
Exactly. So, but we can go inside. Yeah, of course. And then on this side, it's another charging port. And if you turn off the cameras, I'll tell you a dirty secret.
Get on the bus. Another one rides the bus.
Go on the bus.
So this is we've been having this configuration of seating in our buses since 2019, where we went for side seating pretty much down on the side, and so we can add, there's a lot of people on wheelchairs that ride our buses. So we wanted to accommodate everybody. So this bus can accommodate up to 3 wheelchairs at one time. So those seats where you're sitting will also come up, and so 1, 2, 3, and if you really want it, you can go with the 4th one that faces backwards, which is actually the safest position, right? In case of an accident, there's nowhere you can go. You're not going to fall out of your chair. So for safety, we also have, this bus has 12 cameras total, 9 of them are inside, and also we have the screen that all the camera views rotate through, and you can see yourself. This and the rest is marketing stuff, literally. Everybody makes a big deal about USB in buses. We've had USB in buses since 2015. It's not something new. And every single seat set has them.
For USBs?
Yes, you can charge your bus. We have Wi-Fi. We've had Wi-Fi since 2018. It's right here.
Yeah, okay.
And then each single set also has them. So amenity-wise, they're there. Can you turn AC down and close the door? Got really humid.
So I didn't know that you really had that much usage by people in wheelchairs.
Yes. So not only do we have over 1,200 big buses, so to speak, but we also have additional fleet. We have 200 and really. So we have another 295 minivans, literally minivans that are wheelchair accessible because, you know, taxi cab, the yellow cabs went away, and we were actually contracted with Yellow Cab to help us with wheelchair passengers. They went away, we had to take over the service. So we took over that service also. The problem is those minivans run over 250 miles per day, and they're heavy. So we couldn't go to electric again. Plus, there's no electric minivan that I can convert, so I can put a wheelchair in it. So it's not as easy. Everybody says go electric. Well, that's fine, but there's no vehicle that can support our service. And in addition to that, we have Metro Lift, which is our 24-foot buses, and those can also hold up to 4 wheelchairs, and that's where we go to, but the old folks homes, and we take them grocery shopping, or you are in a wheelchair and you call us, we come get you, we take you to your doctor's appointment, we take you back home. So we have all of those services. So it's not just buses that we're involved in, it's across the industry, and the technology is not quite there to go zero. Ford is working on a fuel cell E450 and F450, F550 chassis that will give us that 200, 300 mile range. Maybe then we can move to that. So as of right now, it looks like a lot of the heavy duty industry is kind of slowing down on the electric, and they're going more towards fuel cell because you don't get the range. You're carrying more battery than what you're supposed to carry. So
Now we need a breakthrough in batteries. Yeah.
you know, we've been saying that, what is it, quantum skate?
Yes, I bought stock in that. Yeah.
Oh my goodness, they were like, we're gonna do absolutely everything and we're gonna be amazing. What was it, 2 weeks ago, we released our battery. It was this big. That's the battery.
Either that or electrified roads, but that's without these big buses.
Yes. And then again, you're talking about some sort of electromagnetic, microwave, whatever.
Suppose these cars are brand.
Well, not only that, but pacemakers, hearing aids. I mean, there hasn't been all that testing that everybody says, oh, nothing is happening. It's like, well, stay on it and let me turn it on. No. Well, you said it's safe.
Say for now, for about 20 years.
Exactly. So and also with the induction charging, there's limitations because that depends on it's a very fine distance that you can lose, right? So it's plus minus an inch. So let's say that the city comes over and they repave. Then all of a sudden you lost that inch, or you adjusted the suspension wrong on the bus and all of a sudden you're 3/4 of an inch higher, it's not going to charge. So it's very precise, it's not as easy. Trust me, we looked at all of them, and right now that's what we have on this bus as of today is the latest and greatest, and it's what works. Now, 5 years from now, is it gonna be the same? No. I mean, not even the diesel probably hasn't been the same 5 years in a row.
Nothing changes so quickly because of the internet. People can collaborate in real time world over. One side of the world goes to sleep, another one starts up again, and then they can just easily get all the information from the cloud. They don't have to wait for paper dead trees to read it off of.
I agree 100%, but there's a downside to that, right? I don't sleep because you're always on, right? You are literally always on. You start going down this rabbit hole. What can I do better? What can I do better? What can I improve? And you think you're doing better until maybe just stop. Just stop for a second, back up, start with what's available today, and improve upon what's available today. Do not try to do sci-fi projects.
Right in the sky.
Yeah, just do what's available today with whatever you have available, money-wise. Even if it's fossil fuel, but it's very, very clean. We have to start doing something. So that's what I tell everybody. Is it perfect? No. Is it gonna work? I don't know, but we're doing something.
This is a visit to reality.
Yes.
That you are the king of reality, yes.
I'm trying to be. Usually I'm the pessimist and he's the optimist.
Overall, it balances.
Oh yeah, we need to hear from him
Yeah,
then.
and then it's funny when he's being negative. It's like, hey, that's my job. Let me do my job. You're supposed to cheer me up, not bring me down now.
Okay, what about your ultimate electric vehicle, light rail?
So
When is it going to go out to the suburbs and make it a real?
that one is again. I am not rail. I am bus, but we are limited by legislation. That's all I can say.
Like some communities don't want it. And
Actually, it's written in Texas legislature where we can go and what we can do. So actually, what people believe it or not, we are written. Houston Metro is written in the Texas legislature.
Wow.
So if we want to change our procurement process, if we want to change the way we operate,
God.
we actually have to get the law changed in Austin because that's how we were created. We were not created by the city. We were not created by the county. We were created by the state.
Wow.
We were created by the state for the Harris County, for Harris County.
I guess I was bad mouthing the wrong entity.
Yeah, so we are not actually City of Houston. We are Harris County Transit Authority. So we cover all of Harris County. So that plus. So
Therefore, Conroe to Galveston.
yeah, pretty much, right? Hey, it's a little bit of so we have a shuttle that goes from Conroe all the way to the medical center, just back and forth. It's one of these park and ride buses, and they just ride in the HOV lane back and forth from Conroe to the VA hospital in medical center. It just that's all they do. So it's a lot of miles, it's a lot of people, and that's what I tell everybody. Well, you can get an electric bus. There are electric buses available with 750 kilowatt hour, but you're not carrying people at that point. You're carrying batteries, and how long is it going to take for that bus to charge? Even if you do it overhead charging, I'm still looking at 2 hours, and then I'm frying the batteries because I'm charging them too quick. So there's got to be something in the middle, and that's what we're working towards. Find that middle ground where everybody's happy and we can make it work.
What about solar panels on the facilities to charge these things?
So we are doing that. We are actually starting a pilot project. Not a pilot project. We're not doing any more pilot projects. We're actually doing it. So we have a facility, our west facility. We are going to install 1.6 megawatts of solar panels. And it's going to be split in two. 800 megawatts are going to be dedicated to a backup battery. I'm sorry, kilowatts, I'm sorry. 800 kilowatts will be dedicated to just recharge a backup battery. And 800 kilowatts will be used to just run our facility during the day. At night, if the power is available, we'll use the grid to charge our buses, and we'll use the battery backup to run the facility. We'll have about a 2 megawatt hour battery backup. So that's where we're kind of headed. And on top of that, maybe we'll get some natural gas backup generators. I mean, there's fuel cells, but why use the hydrogen for fuel cells when I can use natural gas?
So does your direct
No.
they give you a 5-year plan?
No, so they don't control us. But they will not allow us to build any more rail. Right? So they don't really control us. We have our charter that we operate by. So the technology at Metro changes as it comes. If we see a technology that has matured, we will go ahead and adopt it in small batches. We'll give it a try. We're never going to go out again and buy 450 hybrid buses in one shot like we did last time. That was bad. that was okay. It wasn't bad, but it was bad.
What aspect of it?
The technology, so hybrids came out, and if you look at the heavy duty industry, it wasn't adopted whatsoever. You don't see hybrid trucks out there. So series or parallel. It just wasn't adopted. You have to remember, a truck has to be cheap enough that an owner-operator can afford it. There's no electric truck right now or a hybrid truck out there that an owner-operator can afford it without some sort of grants. So one, it was weight. The hybrid truck was much heavier. So again, what are you carrying? Batteries, or are you going to carry your load, your 40,000 load, 40,000 pound load, I'm sorry. And that hurt the transit industry because everybody told us the same thing with electric. Oh, trucks are going to adopt it, don't worry about it, jump on it. And well, it sounds like the trucks are not adopting it, they're going straight to fuel cell. There will be electric trucks, but not, you won't see 500-mile electric trucks. You'll see them city delivery, 50, 100 miles, pick up and delivery, that's it.
But Amazon's doing it.
I
Yeah,
was just gonna say, we see the Amazon trucks.
Exactly.
This guy got inside, the driver got out, he said, hey, can I look inside?
but they are crazy. They're going 55 miles per hour down the highway.
Oh yeah.
That's the top speed. And you're driving behind one, and all of a sudden you come up right behind, it's like, whoa! And they're always in the center lane, so that was,
I didn't realize they had a 55
Yeah.
mile top speed.
that's all they drive.
I mean, I could, well, I mean, in the neighborhood,
Yeah,
they're
yeah.
actually, but they go from the neighborhood back to the place where they're picking up the next package,
Yeah.
and that could be a high speed.
I was going to Galveston.
Why didn't they add some gearing to allow?
Well, power, right? The
Oh,
faster
yeah.
you go, the more you use.
But if they're doing it just a short distance.
I don't know, this guy was going to Galveston from Houston, so I don't think he was gonna limit.
So the oil companies, if they're watching, see what we think is a massive shift toward electric vehicles. In order to stay in the game, is it your impression, given that you're exploring hydrogen, that this is something the oil companies would like to do?
Oh yeah, they're already in it.
Yeah.
They're 100% in it. Just because the media doesn't show it or you don't see articles, they're 100% in it. They're not dumb. They know what they're doing.
Maybe it's none of my business. Are you working with
Yes.
oil and gas people? Yeah.
There's certain
You gotta be
things
close
that I
to it.
signed that I gotta.
Yeah, I understand.
But
So that's interesting.
no, they're already in it.
They're all
They are.
on board.
They're very supportive. I mean, like I said, oil is not gonna go away. Period. One way or another, we'll still use it. But can we do carbon capture? Can we
Yeah.
capture all of the carbon and everything else? Because the hydrogen for a fuel cell has to be pure hydrogen. It cannot be hydrogen that it's used in the food industry or in the metal industry. It has to be pure. So when they get that pure hydrogen, they also capture all the carbon and all the argon and everything else. So there's Air Liquide, Air Products, Linde, Shell, BP. I'm missing two. They all have plants around Houston. So I have at least 3 or 4 plants around Houston that I can get liquid hydrogen. So why would I not do that?
Yeah.
And they're getting it from steam reformation.
Steve, yeah. I mean, whatever process I've been to a couple of their plants, and I'm sorry, I didn't see anything dirty there.
And there's green from water, solar,
Yeah, and
water.
And there's that side of it, and that's that's the other side where we can get green hydrogen if we get electrolyzers that are really efficient. Right now, they're really not, and you cannot. The problem is, you electrolyze it to get your gas hydrogen. To transport it, it's not really efficient to do it in gas form. You have to go back to liquid form, and when that's some huge power requirements to get it. So, you know, there's a give and a take in everything you do.
So does this bus have gears?
No.
It's the same as most electric cars.
Yes.
Yeah.
So it's the traction motor goes to a differential, and that's it. The differential here in this one, it's 5.37. 1-to-1. I think so. Yeah.
He was the only person I would mean anything to.
But it can go. We have this bus limit to 63 miles per hour. So, governor? Yes. And it's actually, the traction motor is governed. The RPM of the traction motor is not, that's what we said, the RPM at that cuts it off. He maintains it and...
Service access.
Yeah, we didn't bring a screwdriver. But that would be the...
Yeah, I'm just curious. It makes sense.
Can you steal a screwdriver real quick? Come on.
Go look. But that's the drive one or here, the small one, and then that's to the tractor.
Yeah, it's right under here.
That's the tractor. What is it, a Phillips?
Yeah.
I'll go look. Hold on.
Okay. I didn't think about this one.
That's
It's a pain in the butt to take off.
And this?
This is just the drive line. So the traction motor is right here. Then there's a drive line and the axle is, I'm sorry, the axle is right here. The differential is literally right here. So if we have to tow the bus, you just take this off, you disconnect the drive line because you don't want to backfeed.
Mechanically disconnect.
Right, there's no clutch.
Yeah, exactly. So we disconnect the drive line and we keep going, or we can take one axle out, but that's a messy job, so I'd much rather just disconnect the drive line.
You were saying if you have to tow the vehicle, then yeah.
Yeah, that's, and you tow it just like any other bus. We have 50-ton breakers, we can just pick up the front and go.
Yeah.
We haven't had to tow it yet, but it will happen. There's no bus on this property that hasn't been towed at least once.
Yeah, I mean, things happen on roads, tires.
Oh yeah, if it's a tire, we can change it, but if it's an engine issue, trying to diagnose it on the side of the road, it's just not worth it. I'm gonna have to take a look at it anyway, so just bring it in. We have our own tow trucks. There's 7 of them, and we just run them around, and we put them in strategic places, and as they go down, we just go pick them up, drag them.
So you always have spare buses available to substitute for a...
Yeah, so we try to maintain a 20% spare ratio. Everybody
20%?
everybody thinks that's a lot, but it's not, because you have to do preventive maintenance on the buses, right? Again, even if it's electric, you still have to check the coolant. You have to check the gear oil in the differential and the steering gear box. All of these things have to be checked every 6,000 miles. And on top of that, you have to pay real close attention to the brakes in a hybrid and an electric bus because you don't use the brakes as much. So therefore, if there's a failure, you don't really grab it as quick because the bus has regenerative braking, and then when you really need the brakes, they might not be there. So you have to take the tires, the wheels off, and that takes time. So that's why we have that spare ratio that sounds so high, because at any one time, at least 10% of the buses are in the shops for something. So, and the other 10% are there just in case, or even less than that.
So it's another strike against the hybrids.
Yes.
Then, that you need to up your spare.
Well, no, not really.
You just need to check the brakes more.
Well, so we check them every, so it's our PMI schedule, the preventive maintenance schedule, it's every 6,000 miles. So instead of changing the oil, take the tires off.
Okay. Yeah.
Right, so it's 1-to-1, it's not,
Okay.
it's not really a strike, it's a 1-to-1 change ratio, so.
No, because to me, the idea of
What is
having
this?
a buffer battery in a hybrid seems really good, but you just said
Maybe
that
the
you're
same
sorry
as
that
this.
you bought 450
Like
hybrids.
this.
Well, that's because
Stop
it was
request?
first generation. And first generation, yeah, that's the stop request, sorry. So if you want to get off at the next station, you push this,
okay.
driver knows, pulls over, and
Oh, it's not a button, it's a
It is a
touch
button.
tape.
It is a
it's
button.
a touch
Yeah.
tape.
yeah.
I touched tape.
Touch
That's-
tape.
Yeah, I agree with it.
So being first generation buses, there were some issues. One were the batteries. We went through 3 or 4 iterations of batteries until we found the chemistry that was stable enough to be able to handle transit bus service, because everybody thought, oh, it's a hybrid. You gotta go down the highway, which is what a hybrid is great at, right? You go down the highway, and then when you need power, the engine kicks on, you recharge the battery and then you keep on going, or you go so slow that you don't use all of the battery power available, you use a little bit at a time. Well, a transit bus doesn't work that way. A transit bus, it's 100% on, 0 off. 100% on, 0 off. There's no steady use, and that batteries don't like that. So that's what worked against now the new technology of hybrids, which work more like a diesel locomotive, right? You have a much bigger battery, and then the bus can go up to like 30-40 miles in electric mode, and when it's needed, the engine kicks on and it stays at a constant RPM, charges the battery, turns right back off. And that works now, but that's not what the first generation of hybrid was.
Okay. So it was the generation, not
yeah, so
the
we took
idea.
about 12 years to just get it to the point where, okay, it makes sense. But again, we're going to zero emissions. Are we gonna have zero emission zones? Because if we have zero emission zones, then yes, hybrids make sense. Or you're gonna make me be zero emissions across the board. So those are all questions that still need to be answered. Everybody's making promises, but we don't know how that's going to work.
Yeah, I think that's what the hydrogen industry likes, is zero emission zones, because then they can say, see,
Yeah.
it's only water, yeah.
Well, and again, I'm not a proponent of either hydrogen or battery. What I'm looking for is just something that works. And like I said, we just have to we have to do something.
Yeah.
If 5 years from now somebody comes up with a nuclear power battery that's like this big and it gives me 400 miles of range, yeah, let's do it, that's great. But we're not there yet.
Well, and it also depends on what someone counts as pollution.
Yes.
Okay, so many people think of, what coming out of the diesel bus tailpipe is pollution. But what the oil and gas industry is doing when they're making hydrogen is
It's
CO2 in the
Yeah.
air. But it's over there,
yeah,
at the edge
it's
of
not
town.
over here.
Right, and as you said, everything looks clean.
Yeah.
Because CO2 doesn't make anything dirty or oily or soot or anything like that.
But it's also easier to capture the
Yeah.
pollutants when it's at the refinery.
Yeah, so
than
that's
it is
what
on your
they're doing right now.
Yeah.
Actually, they're capturing the CO2 and they're storing it in caverns in Louisiana. I don't know if you knew that one.
Yeah, I heard that one, but no thanks.
Water?
Well, thank you.
Yeah, the whole capping leaking gas wells.
Yes, in Texas.
Yeah.
In Texas in particular.
A
Yeah.
lot of them too, right?
There's abandoned wells out there that they just walked away from and yeah.
So there's the operating wells that leak and the abandoned wells that leak,
Yeah.
and how much of that is measured and captured.
All right.
Halliburton said that they're moving to all hydrogen power generation in their oil field.
Ah, wow.
Pull up.
But they got to truck it in,
Oh man! All right.
right?
Yeah. They probably got to truck it in, whatever it is.
Well, you learn something.
Don't want to move?
Hell no. Does it ever?
No.
It seems like with
There
that
is
L
no-
shape, it should help it.
There is no finger
Molded
latch or
perfectly to the
anything.
hole that there is.
Now, get out your complaint list.
You didn't bring a flathead, did you?
Maybe the engine has to be turned off.
No.
Oh, I saw movement.
Yeah. That's a positive.
Come up, please.
So close.
Yeah, so close.
It has coolant and oil in it.
Oh my gosh, that's the main traction motor.
Yeah. That
Water
is a
cooled.
beauty. I love it. And cooled, yeah.
That's just a three-phase big induction motor
Yeah.
with a few wires.
So it's the same motor that they're using hybrids. That's why you see it has a bell housing where you can attach directly to a diesel engine. It has the same pattern.
Okay.
Oh, okay. Yeah.
So,
Wait, I'm sorry.
so
That's the motor.
this is the motor, but
That's
there's
the
usually a diesel engine that's attached to the other side of it, right?
Okay.
It's
a hybrid.
Yeah, in a hybrid. So this bus The difference between this bus and a hybrid bus, it has more batteries and no diesel engine. That's it.
But
Wow.
traction motors.
Everything is the same.
Yeah, that's great that
I
we can
found
do
this
that.
on
Oh,
the
yeah.
seat. Is that
No, it's
that's important?
yeah. I think. Oh yeah. Well, you know, you should have brought that to start with.
What was the
Oh,
trick?
that's a beauty right there. Yeah.
Yeah, that'll get to that.
That'll do it.
This certain angle you gotta pull on it or what?
No, you just gotta make it clear.
This edge.
This, and it's hard plastic, so it just needs to clear that edge, and then it just literally comes up.
So when would you remove that? In case you have to remove that motor?
Yeah. So this motor, the bearings need to be replaced in it every 6 years. Just the bearings, and that's it. You put it back in, and because they're wet bearings, right?
Ah,
So they stay in a bed of oil, but just for inspection purposes, every 6 years, take it out, replace the bearings, and move on. Can they last more than 6 years? Yes. Does anybody know how long they last?
Yeah.
No.
No,
So this is
that's-
6 years.
right. Well, if you figure it's going to go 12 years, then that's
Yeah.
right in the middle, and then it's done.
Exactly.
12 years.
Grab that side. Grab that side.
I'll grab it.
Okay.
Yeah.
What are we doing there?
Yeah. Well, looks like it does drop out from the bottom too, right?
Yes.
Yeah. Well, that
This is just there's really nothing there's nothing to inspect because he has sensors everywhere and will tell you I'm low on coolant, I'm low on oil, I'm not healthy, and then the computer constantly measures the power draw of every single component, and it will tell you after a while, hey, this one it's using a lot more than what usually uses, and they also know how much amps are supposed to be drawn. So if it goes above a certain amperage, cuts it off.
Makes the bus move. All right.
We were on Pacifica, we were talking
Yeah.
about the plan and preaching the gospel of EVs.
You know,
I don't know if you.
he's telling your friend there, they're always looking for speakers on KPFT radio.
That
Have an hour.
has to go through public relations. I can't.
Go out and do it.
Yeah, we're just talking technical world.
Yeah, I can be rogue, but I might not have a job when I come back. So I like my job right now. Then I come from trucking. Right? That's my background. I used to work for Packard, Peterbilt and Kenworth. I was their maintenance specialist. I would be the guy that would show up with a laptop to your dealership, plug up, and tell me this is wrong, that's wrong, that's wrong, replace that, then I was out. So then.
But you're ready to give up diesel engines now.
Well, yes and no. I'm ready to adopt new technologies.
Okay.
I'm not giving up diesel engines. There's a place for diesel engines.
He worked and drove tanks.
Yeah.
Electric,
For a small time.
electric tanks.
They weren't electric, they were turbines.
Okay.
Well, I mean, it's like we were talking about horses. or Robert was talking about horses. I mean, people, left horses back in 1900, 1910.
That's the thing.
Well, at the same time, we had electric cars all the way as early as what, 1905?
Yes. Yes.
And the range was like 100 miles, right?
APA.
That range did not change for close to 100 years. And then all of a sudden it went 200, 300, and so
Exactly.
Oh yeah.
what is going to happen in the next 10 years? I don't know, and that's why I tell everybody, it's like, stop trying to just pigeonhole somebody on just one. Just start, slow, adopt, and move on. You cannot just say, this is what we're doing like California did. We're going to be zero emissions, all electric. Good luck.
That's it. And during World War I, there was a lot of wood burning engines out there. I
Yep.
mean,
Steam,
steam,
engines.
yeah, all kinds of crazy things.
Yeah.
So, I mean, there's technologies out there, slowly but surely, they're coming around. Whatever it's cleaner, better, we'll figure it out.
And it's a matter of the use case. I mean, these guys have heard me say that I've been in this club since 1994, and back then, people would take a forklift and take out the traction motor, because the forklifts working in warehouses were great when they were electric, because people working inside could still breathe. They weren't going great distances. The lead acid batteries provided a great counterweight so you could lift things up with the fork. And so people would take their car with a blown engine, take the traction motor out of a forklift, put it in their car, and add batteries, lead acid batteries, and convert their gasoline car that had a blown engine into electric. Because the forklift motors were out there. I mean, they were built in large numbers for warehouse use of forklifts.
So I don't know if you know, but now most of the warehouses are switching over to hydrogen forklifts.
Are they?
Yes.
Ah, I didn't know that.
Because of downtime, right? So instead of having 60 forklifts, well, you charge one and you use one, you can have just 30 forklifts, and it takes a minute to put a kilogram of hydrogen into the forklift, and it's just continuous. There's no downtime, there's no charging ports. Coca-Cola, Amazon, Home Depot, there's a few more.
Is it fuel cell or is it?
Fuel cell.
It's fuel cell, okay.
Fuel cells that are provided by Plug Power.
And is it because they're running their warehouses 24/7?
Yes.
And that's why, okay. Because probably back in the night.
Yeah, Walmart, sorry.
Budweiser.
Yeah. No,
So I can actually take you, well, I don't know if I'm supposed to, but let's say there's a huge warehouse around Beltway 8 and 45 North, that industrial parking lot back there. You should just drive around and you will see something.
Okay.
Just saying.
Yeah.
Here, I'll go, because you make a recording. I missed that.
Hopefully I got it.
No, but that's what they're going for, just because of downtime.
Right, no, it makes sense.
I think it's a 25 kilowatt fuel cell.
Yeah.
And they actually have to add weight to be the counterbalance, because you take the lead acids out, they don't have that 6,000 pound weight on there, and they actually have a water capture tank because you don't want water everywhere. So while they fill up with hydrogen, they dump the water. Yeah, so it's really interesting how.
Kind of the opposite of steam engines.
Yes.
Steam engines, you added water, and now you're draining the water.
Fuel cells have become reliable and
30,000 hours.
30,000 hours, okay.
That's the lifespan of a fuel cell. Now, 30,000 hours is not continuous, because just like I said, the fuel cell does not turn on and stay peak at all time. It's just like sine wave, right? It just gives you full power, then comes back down, full power, comes back down. And the usable life of a fuel cell that's 100 kilowatts, once it gets down to 80 kilowatts, it's out, it's done. You take the packs out, put another pack in.
So they tend to degrade. They don't just stop working.
No, they just like batteries, right?
Yeah,
what's a fuel cell? It's a reverse battery.
Right,
So,
but I didn't know what their failure modes might be.
Yeah, so it's about.
I was imagining that they would run until they break.
No,
but
so
they actually degrade.
And then what happens? They start using more and more hydrogen to provide the same amount of power. So then it's not worth it.
Yeah.
So 125 kilowatt fuel cell, once it gets down to 100, it's done. So it's about a 20%, just the same as the batteries, right?
Yeah.
Just under 100, once you get down to 80.
Right. Well, and that's a constant use warehouse. There may be some other smaller warehouse that moves pineapples and they don't care how efficient it is, and they can do it.
Well, these are the big guys, so...
Right, that's what I'm saying.
If you look at the big guys and they're moving towards that and they're giving up the electricity, it's kind of... Okay, so they're doing it because of cost. They're not doing it because they're green.
Yeah.
So to them, going to hydrogen forklifts is cheaper and more efficient. So
if you need half as many forklifts, that's
So
less
is
capital
there
investment.
any special safety considerations for the hydrogen forklift?
no. They have optical sensors everywhere, just to make sure that there's nothing leaking. But it would be the same as running propane in a
I was just going to say,
right?
gasoline,
It's
propane,
another-
you got just as much.
I mean, how many years did we run gasoline and propane inside buildings and nothing happened? Now we're picking on one fuel because it's
Right.
that's the only thing that, like I said, we gotta try something.
Can we get a spin? Yeah.
Let me put everything back in.
That's,
I can't-
that's
I-
great.
I
to
gotta-
see the
I gotta-
liquid cooled motor. Yeah.
Say I rode an electric bus.
Oh goodness, this is heavy. Do you remember this being that heavy? 'Cause I don't.
It's got to be sturdy enough to have all those kids jumping up and down on it. Maybe you jumping on it too. I was just going to say, the way you're going to put it in, I bet you're going to jump on it.
Yeah, I'm done with this. I'm not taking this off again.
Yeah. Very good. We appreciate it.
Yeah,
That really showed us a lot. Yeah. So it's one single motor. Because, you know, some designs of vehicles like Rivians, they put a motor on each wheel.
Yeah, but then you have 4 motors that can go bad.
True.
So what we're doing, we're going for simplicity, and we'd like to have the same platform, right?
Yeah.
So I have this exact same bus, I have it in diesel and CNG. And the only thing that's different is the propulsion. So I have the same axles, the same windows, the same suspension, absolutely everything. So
Yeah, it makes sense. No, commonality brings you a lot. Yeah. Absolutely.
done. I gotta close everything outside.
Yeah.
Here you go. Set. I'll close everything outside.
All right, get off the bus?
No, we're gonna go for a quick ride.
Right.
Oh, cool.
Yeah, you may not have heard me say that.
No. I'm going for a ride.
Yeah, this is great. All right.
They're gonna return the tools, is that what they're doing right now?
Yeah, they're getting things ready. And they opened up some other things. So,
Oh, they gotta close all that.
yeah. So this is just like what you did in the Amazon truck. You got to take pictures.
I've not seen that truck since.
Oh, I've seen a few of the Amazon electrics going around Houston. And,
Alright, I'll get back here. We're just gonna take you around the parking lot if you don't mind.
Sure.
Because going out on the street, there's still traffic and I don't trust them.
All right, hold on. Put your seatbelts on.
They're not mandatory in the transit bus, but they're mandatory on a coach. But,
really? They are mandatory? Coach, I didn't think.
Coach me.
like, they have to have it, but that doesn't mean you have to wear it.
Okay, so it's not mandatory to wear.
Yes.
It's mandatory for you
Yes.
to provide it. Okay, I got you. Yeah.
Which is great.
Well, this is slick.
That's slick.
Oh,
It
this
is, yeah,
this
feel
is
the difference.
great. Yeah.
Oh my God.
Here we go.
Oh my gosh, that's fine.
Gun it, Seth, gun it.
I mean,
Let me get on the straightaway. Who
I
will?
ride Metro bus frequently. This is a new experience.
It's quiet.
So we're on bus 3000.
Yeah, this is the first one.
Oh my God.
Wow.
Does the driver really like it?
Yeah.
Yeah.
So, this is as loud as it's gonna get.
My stress level went down
Is that-
tremendously.
And we can have a conversation. And even when we're going down the highway at 60 miles per hour, is there traffic, Seth?
What?
Is there traffic?
I gotta go.
Not really, I don't know. Why?
Hit it. Just get on the service road real quick to the next line and back. U-turn. Alright, we're gonna go a little bit out.
Grab a thing.
We're gonna cut loose. Huh?
Yeah, one pedal.
How's-
I'm only using one pedal.
Have you used the brake at all?
Yeah, so
No.
the bus will slow down all the way down to 3 miles per hour, and then you have to touch the brake.
This is slick
And
as
we
slick.
did that for a safety issue, right? Because the door is not supposed to open unless you go below 3 miles per hour. So we want the driver to push the brake and stop.
That
We
is
don't want
powerful.
the bus to be the
That is good.
sliding off.
One pedal drive.
So just hold on because the region is aggressive. Just letting you know.
Yeah, I was on the Grand Canyon rafting recently. Talk about holding on.
Oh yeah.
All right.
Yeah.
I feel the difference in the
Oh, that's.
ride the bus outside of our facility. So this is our own little secret right here.
This is fantastic.
Hope you guys enjoy it.
Yes, we are.
I was just telling your trucker drive that go to our website. We've got a Facebook link to it, and it lists everything about EVs, planes,
That's
cars,
and a wheelchair, right?
school buses, work buses, and it says everything about the electric buses the world over, electric school buses nationwide.
So are you gonna make a U-turn down there?
So as you know, there's battery electric, there's fuel cell electric, they're all electric vehicles, right? Are you guys agnostic, or you're just more towards battery, or you don't really care just as long as...
I would say we're agnostic because as well as within the battery electric vehicle, so many manufacturers now. I mean, we know that Tesla is leading, but they may not always lead.
Yeah.
So we'll see. But yeah, I mean, it's kind of the drivetrain, and we also have a lot of people learn about the lifestyle. I often tell people it's easier for local driving, but requires more planning than long distance driving. So with most people, 50 weeks out of the year, they're doing their local driving 2 weeks, and they go on a trip, and I tell them, go rent a gasoline car for 2 weeks, but for the other 50 weeks, drive electric.
Yep.
You wake up every morning, it's like Groundhog Day. You got a full tank of electrons.
To be honest, I just go to work, go home, and then the only time I drive my personal vehicle is we take the kids to the beach. Right now, we're in that
Feedback,
we're in the beach, everything else. So I kind of need
program that
plus I have a travel trailer.
Oh yeah.
So I do
Yeah,
need
move.
that
You're good.
that big truck for a while. But I know how my bus are done, the kids are in high school, I'm done.
So, always not go out and add
Smell of gasoline, the rest of it getting caught in a hold up, and
smell from my wife doesn't like.
I used to love the smell of gasoline. I know it's not good for you, but I used to love it.
So what's funny, when we first got this electric bus, I thought that I was going to miss that which is amazing. Everybody likes turbo's, I don't care. But to hear that turbo's cool off, but I don't. I actually enjoyed it. It's also means I can talk to you when we're doing 50 miles per hour, and it's louder outside than it is here. It's just...
It's a ride, yeah.
A couple of years ago, we had talking about electric service trucks that were and they were afraid that alignment would have like different repairs. They found out one of them is they can get the engine running and they can talk. So they can stop the guy at the bottom, they can talk and not have to yell over the sound of the truck because they were all they loved it. And they would fight over who would get their first trucks.
And that's where I believe that...
Turn camera.
Yes, sir.
That's the right side?
That's our left side.
That's the left side. Okay, yeah.
Idle time. And you'll be perfect for that.
Left is left, right is right, and then when I open the back door, it'll show me the back door.
You want constantly.
And there's also a reverse.
That's hydraulic power. When you need to move, bring back down. The EC times it doesn't use that much power. You can get away with 60 kilos, 100 kilos. Right? You go from your shop, you go over in the city, fix the transformer, you need to come back to shop, right? Those are not type of vehicles that run for 2,400 miles.
It's a complicated machine.
You have to
Well, I mean, that's good.
Well, I mean, it's got to have all these other things. It's got to have Wi-Fi. It's got to have, you know,
yeah, there's a use in the spot for it.
electronic sign up here. It's
Oh, God. Wait, nothing of the reporting where you are, so Google Maps can tell you when the bus is going to arrive?
oh, really?
Oh, yes, yeah.
I mean, it's pretty full of technology. Lift for wheelchairs, man.
If I could get a picture of Lisa in the car.
They haven't did anything on this bus or anything on this. It's not hard. I mean, to replace the battery with the overhead crane on this bus, they take 2 hours. The batteries up on the ones underneath take the same. It's just, we've already done it. We're already there. We just need to have a refresher, and we need to remind us that, hey, instead of 50 kilowatts now, we have 500.
I walk on these trees with our height running into the top of the bus.
Oh.
Right in the middle. Gotta avoid as many as I can. Those are gonna go right across the top of the bus.
Yeah, you just don't think, I wouldn't think about that.
I think about when I went downtown for an early day, I had to go through all the trees downtown. It's quite fun.
Don't just.
For the first 20 buses, I assume you'll have factory replicators, supervised, set through repairs, maintenance.
You hear about, in Europe they're doing away with mirrors, right? Side view mirrors?
Oh, they have cameras.
Yeah.
instead of mirrors.
Yeah, but eventually we're supposed to get that too.
Yes, they have some. They haven't gone to that.
Hard for me to imagine. Yeah.
I can't imagine it being without.
I can't either. Yeah. I think a new generation of kids to learn how to do that.
Yes.
They want to see how we're going to use it.
Well, they all, where else can you go to autonomous driving? That's a whole other.
Oh my God. I cannot see it. Yeah.
Well, actually, to be honest, our average speed for 44 transit buses is about 13 or 14 miles per hour. We go fast, right? Because of our speed limits are high. We don't go for 20 miles per hour. But since this bus is going to run around the medical center area, medical center all the way to my driver's take the back, and then medical center all the way downtown and back. So there'll be 2 routes that they will just meet in the middle. So
I like that.
yeah, I mean that's what we were thinking too. The whole, where should we do it? Let's start at medical center first, and then we'll spread it out. After we park it and we apply the brakes, and you promise not to touch buttons, we're good. Oh, of course. No buttons. We took when we were at Earth Day.
You okay to be coasted?
Yeah, we're
Pacifica radio call station.
Yeah. It was funny at Earth Day because we wanted kids to get interested in it, and I have kids. But my kids, when I tell them don't touch the buttons, they understand, don't touch buttons. And I thought that most kids are like mine. And I was wrong. Because we're letting kids jump on the seat, and then we told them, hey, you can turn the steering wheel, play with the horn. And then they turned their head and they would see all the buttons and just, oh my, it's like, all right, no more kids. No more kids in the seat, we're done.
This is exciting.
All right.
Okay, would you take a picture of me sitting in the car seat if that's feasible? And I think we all would.
They want to take pictures in the driver's seat, so.
Do you have any diagram right now? Yeah. Okay.
All right, dude.
There you go.
My God. This is a dream, right? Never sat in a bus seat in my whole life.
It's like being 12 years old again.
I've driven one of those 25-foot U-Hauls
Hang on a
before.
second. Gotta get into it.
Never a bus.
All right, look this way.
Metro!
Metro. Okay, very good. Yep, I got you.
You got it? Let me see how to get out of here without stumbling. If anybody else wants to.
Yeah, here.
Oh, who's
Dave. Oh, that's good. Same with you. What do I do?
You was fine.
Oh.
How many ways? Metro Bus.
Yeah. All right. Yeah, this is great to see the
Is this an iPhone?
343 miles only. That's great. 3.4 average kilowatt hours
No,
per
that's
mile.
not the true one. It's been sitting on all day. Don't go. No.
Not the real numbers? Okay.
So actually, 10 degrees, we get about 2.25 kilowatt hours per mile. So, and empty is about 1.7. You can take one of those.
Thank you.
That's a spec sheet. So that's the whole.
That's the whole thing right there.
Yeah. So it says confidential on it. So, but I can give you this one, which is the highlights.
That's great.
That tells the battery power and absolutely everything.
Excellent. Thank you. You guys have gone way out of your way. Thank you so much,
Well,
man.
We want to show people that we actually do care.
It is impressive. Yeah.
Reapplying it. You reapply.
This Thursday.
Really been fantastic.
It is.
Really glad to hear everything that.
No problem.
Yes, sir.
Thank you. Oh, thank you.